So Chapter 7, Video 6 is a continuation of Section 7.5. So we're going to keep going and look a little bit more at our scale drawings. So our first target here is to solve word problems involving scales. So if there's a scale or a scale factor in the problem, we're going to learn how to set up proportions to solve for a missing length or distance. Target 4, and this I'm starting at 3, 4, and 5 because this is a continuation of video 5. We're going to calculate lengths and areas of scale figures. So they might ask you for perimeter, right? Adding up all the outside edges of a figure or finding the area of a new figure after you've made it bigger or smaller using a scale. And then also reproduce scale drawings at a given scale. So actually redrawing it at a different scale, so in a different size. Okay, so these are kind of out of order. I want to show you that this is actually target 4 here, calculating lengths and areas of scale figures. So if I give you a problem like this, you start with a square and it has dimensions 8 feet by 10 feet. And they tell you to use a scale of 2. Well, you're always going to multiply by your scale. So everything is basically getting twice as big. Instead of 8, then it would be 16. Instead of 10, it would be 20. So you need to understand that whatever they tell you the scale is, you're multiplying by that to get your new numbers. Or if I started with a rectangle that was 14 by 16, and they tell me to use a scale of 1/2, well, I'm still going to multiply by that, but I could multiply by a fraction. That just means things are going to get smaller. So what's half of 14? Well, I know that dimension would be 7. What's half of 16? That dimension would be 8. So in this case, a scale like 1/2 means it's half as wide, half as tall. What about here? If I start with a triangle that has side lengths of 4 and 5 and 11, we're just going to use these numbers. That actually doesn't make a triangle, but let's go with it. So a scale factor of 3 means everything is going to get 3 times as long, or 3 times longer. So 4 times 3 would be 12, 5 times 3 would be 15, 11 times 3 would be 33. So you know that if they give you the scale, you're just multiplying by that scale. How about 1/3? Well, what's 1/3 of 12? We know, and I should have mentioned this up here too, we know if we're multiplying by a fraction, that would be the same as dividing by this denominator. Multiplying by 1/3 is the same as dividing by 3. So 12 divided by 3 would give us 6. Nope. 12 divided by 3 would give us 4. 21 divided by 3 would give us 7. Okay? Same thing up here. I could multiply by 1/2, or I could recognize that that's the same as dividing by 2. Okay? If you have this in your notes, then when you see questions like this, you'll remember, oh yeah, I'm just dividing by 2 or dividing by 3. Here's our last one. If we tell you the scale is 5, you're just going to multiply everything by 5. It's getting 5 times longer. So 4 times 5, 3 times 5, 8 times 5 to get your new dimensions. Okay, so these could be written like this, or they could be given in a sentence. It might be more of like a story problem that says, hey, you had something that was 8 feet long, you're making it bigger by a scale of 2, what would it be now? Okay, so we can see that we're just multiplying by the scales, okay? Or we could see it written as a story problem. So again, this would go back up here, more of like target 3. Solving word problems involving scales, okay? So I want you to write down, here's our practice problem. A map has a scale of 1 centimeter equals 6 miles. That is the scale of the map. How far are the two cities apart that are 3.4 centimeters apart on the map? How far are they apart in real life if they appear 3.4 centimeters apart on the map? Well, this is what I want you to write down as your hint for these ones. Always take that scale that they give you and use it as your first ratio in your proportion. So I would write down that 1 centimeter goes with 6 miles. That's my first ratio. And then I'm just going to keep reading and line up my next number that they give me, my third number. Okay, the two cities are 3.4 centimeters apart on the map. Well, this is the map. This is real life. So 3.4 centimeters apart on the map. How far in real life? And then I would cross multiply. Okay, here I actually have an easy arrow if I want to use it, right? Times 6, you could do that. And I got 20.4 miles, because these units down here are miles, apart in real life. Okay, let's try another one. Scale drawing has a scale of 1 inch equals 12 feet. Here's my scale. I'm going to write that as my first ratio. 1 inch on the drawing is 12 feet in real life. How long is a wall in the drawing if it's 64 feet in real life? So I know I'm looking for how long is it in the drawing if it's 64 feet in real life. And I can use my units to help me make sure it's lined up. Also, this is the drawing, this is real life. Drawing, real life. Those should be lined up as well. And then I would cross multiply. Or you can look for an easy arrow, right? This easy arrow could be times 12. No, sorry, we're going this way. Divide by 12, divide by 12. Type that into your calculator quick. And I got 2.83. And my labels have to match up here, so inches. Okay? All right. So I want you to pause it and try this one. Set up your proportion right here. And then find how long is the model train if the real train is 92 meters long. So pause and do this number 3 here and then hit play when you're ready to check. Okay, here's what I got when I set it up. Make sure you have model, real life, model, real life. And then if you're looking for an easy arrow, a lot of times these will have them, right? I can always I'm going the other way. I can divide by 8, divide by 8. So when I did that, I got 11.5 centimeters for the model train. Okay, and that brings us to our last target here for this video and for the chapter, and that is to reproduce a scale drawing at a given scale. So here's my original. This is my original little rectangle there. The lines are kind of hard to see, but each of these is a block of 5. So this original drawing is 2 by 3. So 2 wide, 3 tall, or 3 long here is my original drawing. So it says find the original area and the original perimeter. Okay, well, area would be 2 times 3. So I know I get 6 square units. And then perimeter, I would just add up all the outside edges. So 2 plus 3 plus 2 plus 3, back to where I started, gives me an original perimeter of 10 units. Okay. Now it says reproduce the figure using a scale of 3. Well, just like we saw up here, whatever your scale is, that's what you're going to multiply by. So instead of a side length being 2, if I multiply it by 3, now I would get 6. And instead of this side length being 3 times 3, now it would be 9. So I'm going to start over here in this corner just to keep it organized. You could put it wherever, but that'll just help me count my numbers a little bit easier. So now I know I want it to be 6 wide. So that's 5. And to there would be 6. And then 9 tall. That would be 9. Okay, so everything just got multiplied by 3 to make this new figure if I reproduce it at a scale of 3. So now I'm going to write that this is 9 and this is 6. And then they ask me for my new area. Well, 9 times 6, right, to get that area would be 54 square units. And perimeter is just going to be 9 plus 6 plus 9 plus 6. So that gives me, what, 15 and 15, 30 units for the perimeter there. So you can kind of notice that this perimeter got 3 times longer, and actually this area got 9 times bigger. We'll talk about that more. You'll look at that a lot more in 8th grade. We just want you to be able to calculate area, calculate perimeter. Okay, do it one more time. Reproduce the figure with a scale of 1/2. So now, instead of 2, I'm going to cut it in half and get 1. Oops, that's not in the right spot. And then instead of 3, I'm going to cut it in half and get 1/2. So everything here is going to be, I'm going to say multiply by 1/2, or we talked about how that is divide by 2. Okay, so a width of 1, and it's only 1/2. So it would really only be this big. 1/2 on that side and 1 on that side. So it's half as wide, half as tall. Okay, well, calculate the new area now. Well, 1/2 times 1, length times width, is just 1/2. And then the perimeter, 1/2 plus 1 plus 1/2 plus 1. Let's see, 3, 4, 5. Okay, so I'm going to zoom out and make sure we got everything we need to out of this video. Okay, look back over it. If we give you starting dimensions or lengths and tell you the scale factor, you should be able to calculate what the new lengths will be. Again, this could be written just like this, or it could be in a sentence or a story problem. Okay, so for these, you're just multiplying by whatever the scale factor is. Remember, or the scale. Remember, if it's a fraction, you're really dividing by that denominator. Cutting something in half, dividing by 2. Cutting something into thirds, dividing by 3. The next couple problems, we were given a scale, and we used that scale to set up a proportion. So the scale in the problem is always going to be your first ratio, and then finish filling in your proportion and cross multiply or find an easy arrow for the missing number. Make sure you label everything. Usually it's either like the map or the model or the drawing on top, real life on the bottom, and then make sure things are lined up. So again, they gave me a scale. That's my first ratio, and then finish setting up my proportion and cross multiply or find easy arrows. Okay? And then this last target was to reproduce a scale drawing at any given scale. So they're going to give you a figure to start with. You're going to know what the scale is, so all of your lengths, side lengths, need to get multiplied by the scale so that you can figure out what the new lengths will be, and then you're able to draw that on a grid or a graph paper like this. After you have your new drawing, we can calculate the area of that, we can calculate the perimeter of that, okay? And like I said, 8th grade will go a lot further kind of with this relationship, but you just have to be able to draw it, find the area and perimeter, okay?